The next question in your end of chapter problem reads something like this. You will have different numbers. Assume that mitochondria are cylinders, okay, 4.50 micrometers in length and 0.700 micrometers in diameter. So again, we have a cylinder. Oops. I will get to that in a minute. What is the volume of a single mitochondrion? And the volume of a cylinder is given by this expression. So I think they're probably shuffled. This was one of the easier problems. The last problem that I did was a little more complicated. So probably they were shuffled for me, and I got the more challenging problem first. Alright, so these aren't really difficult if you know how to work them anyway. So for question 2, okay, let's go back. We've got, assume that mitochondria are cylinders 4.50 micrometers in length and 0.700 micrometers in diameter. Okay, so let's draw out a cylinder. My drawing skills are not that great, right? And so it's 4.50 micrometers in length, and the diameter 0.700 micrometers. Okay, let's make sure that's right. Okay. All right, and so our volume then, as you know, we just worked one of these, is equal to pi r squared times the height. And again, our diameter is 0.700, so in order to get the radius, we just need to divide that by 2. So we can go ahead and put this whole thing in, make it a little simpler. 3.14 is pi, we'll just use that. 0.700 times 10 to the minus 6 meters. Okay, so because we have micrometers, so we're going to go ahead and convert that to meters. Okay, then let's divide that by 2 to get our radius, because radius is half of the diameter, and we need to square that. So that's pi r squared times the height, which is 4.50 micrometers. And notice that I have the cylinder on its side. If I had drawn it straight up, then this would be the radius and this would be the height. The height is equal to 4.50 and the radius is equal to 0.700 divided by 2, right? Okay, and so I'll go ahead and work out that. Volume is equal to 3.14 times 3.5 times 10 to the minus 7 meters, okay, squared, times 4.50 times 10 to the minus 6 meters, okay. I should have converted that to meters here, sorry. And then the volume is equal to 3.14 times 1.225 times 10 to the minus 13 meters, squaring this right here, times 4.50 times 10 to the minus 6 meters. And so the volume is equal to 1.731 times 10 to the minus 18 cubic meters. Okay, so that's working all that out. You get 1.731 times 10 to the minus 18 cubic meters. Okay, and so if you want to convert that to liters, 1 cubic meter is equal to 1 times 10 to the third liters, and that is equal to 1.731 times 10 to the minus 15 liters. Let me erase this, that don't look good. Minus 15 liters. Okay, if we convert that to liters, okay, because what was I going to say about that? I was going to just say something about that. I don't remember. Anyway, I think they ask you for it in femtoliters, and so 1 femtoliter is equal to 1 times 10 to the minus 15 liters. Okay, let me go down a little bit. Sorry about that stray mark. And that's equal to 1.731 femtoliters. Oh, that's what I was going to say. Let's look at our sig figs. Okay, so we've got 3 sig figs here, 3 sig figs here. So that means that our answer is going to be 3 significant figures because we're multiplying and dividing the whole way. So that's 1.73 femtoliters. Okay, so that's my question 2, and we'll get to question 3 next.